A scatter plot, by definition, is a graph with plotted points. A scatter plot is a graph with plotted points. But it's more than just a bunch of points, right? The points, the plotted points, the dots, the graph itself shows a relationship. This is bivariate data, meaning two sets of different variables. And how do they relate to each other? Is there a relationship? Yes, no. What kind of relationship? It's basically just a bunch of dots. It's a scatter plot. The word scatter means non-linear, right? They're scattered around.
Yeah, they're everywhere.
Right? A scatter plot is a graph with plotted points, so it's made up of ordered pairs. Those pairs show a relationship. It's just a bunch of dots. There's no lines, nothing's connected, no bars, any of that.
So this is 8.
If you think back to the beginning of the school year,
So this is discrete.
this is a discrete graph.
Linear plots are continuous.
A discrete graph is a bunch of dots. We talked about discrete graphs. An example of a discrete graph, like if you're graphing the number of dogs you walked, if you're a professional dog walker, you could not have walked 2.5 dogs. That doesn't work.
So if can you do a babysitting example of Paul and Mrs. Newer? Remember the babysitting example?
Yeah, babysitting. Mrs. Newer doesn't charge me for 2.5 children because there's there's 2 kids that belong to her and maybe the neighbor's going to come over. Right? So with scatter plots, there's something called a correlation. Man, our delay is bad today. Correlation is in another word. Sometimes you'll see association. Or it's just called a relationship.
I should make these flashcards.
Correlation, association, and relationship, all same term. Different vocabulary, same definition. It's asking you what's the relationship. Is there a correlation? Do the two correlate? What's the association? If something happens, can you predict from there? And there are 3 types of correlation. The first one is positive. For those of you that are on Twitter, think of it in Twitter world. A positive correlation is trending up. What does that mean if something's trending up? Does that mean that everybody's talking about it? No. If something's trending up, does that mean that 5 minutes ago compared to now, there are more people talking about it now than 5 minutes ago? And then 5 minutes from now, will probably more people be talking about it? Yeah. Trending up doesn't mean that everybody's doing it, but it means that as time progresses and the word gets out, more and more people are talking about it. It's trending up. If there's positive, there's also negative. Negative correlation. Positive correlation is trending up. 5 minutes from now, more people will be talking about it. 5 minutes from then, even more people will be talking about it. If it's negative, it's trending down. Meaning fewer and fewer people are talking about it. It's losing its steam.
Oh, but what if one person will just not stop talking about it whatsoever?
Then it's neither trending or trending up or trending down.
Just staying the same.
So the third type is neutral.
The next one is none. There's no correlation. It doesn't affect anything. It's not changing or it's completely random.
It's like dividing by 0.
No, it is not. Because it exists. There's no change or it's completely random. There's no change or it's completely random. Within positive correlation, within negative correlation, there are things like, or adjectives like strong or weak. Positive. A positive correlation, these are not going to be pretty graphs. They're going to be quick and dirty graphs.
But what if I make them quick and clean?
Go for it.
You cannot have a ruler to help me out. So, hallelujah.
But there are no straight lines in our graph.
Just get busy. Yeah, it's a scatter plot. You need to be sitting down or, yeah, that works too. Add a counter someplace. Do it.
This is a positive correlation. I'd say it's even probably positive, a strong positive correlation.
It's pretty steep.
Remember we talked about the parent function for a long time that's perfectly diagonal?
Y equals X.
I mean, that's pretty close to a parent function. It's pretty right in the middle. We'll talk about that in a second. As x increases, y increases. If I'm a waitress for my job, the more hours I work, if I only work, 1 hour, I make $10. But if I work 2 hours, I increase my time, my money increases. If I increase my x, my y value also increases. As x increases, so does your y value.
And I built a trend line for it too.
We're not there yet. Hold on. So let's talk negative scatter plots. It's not my best scatter plot I've ever drawn.
You just want to make a quick one?
Yeah.
So doesn't this call all the way back to our data unit?
As x increases, so as we go along our x-axis, what happens to our y number? Our y decreases. So this is maybe if I spent $5, I still have $100 in my savings account. But if I spend $10, I now have $90 in my savings account. And if I spend $20, I now have $7, right? As one increases, the more money I spend, one decreases, the less money I have saved. And then we have none, or no correlation, or no relationship, or however you want to say it. And none looks pretty much like a blob.
Yeah, but a correlation exists. It's not divided by 0.
Correct. It's random.
It's like all over the place.
So like an example of a random correlation, the number of books at your house and the number of t-shirts you own. No relationship. One does not affect the other. The number of brothers and sisters you have and the number of TV channels you get. They don't have a correlation. They don't affect each other. So to take this even a step further, to talk about scatterplots and to talk about their relationships or their correlation, we talk about something that's called a trend line. If you end up looking it up, if you think to yourself like trend line, I don't remember it, sometimes it's also called line of best fit.
LOBF.
And trend lines show correlation. Trend lines show correlation and are used to make predictions. Trend lines or line of best fit show correlation and are used to make predictions. And the hard part about this is that it's an estimate. And the struggle with estimates, gentlemen, make sure you're listening and not talking. The struggle with estimates is that there are lots of correct answers. Your answer may be different from your neighbor's answer, may be different from all the people at your table's answer, and still be okay. But an estimate can be wrong. And that's where we struggle sometimes, of figuring out what's a good estimate. Because you panic and you get worried because there's not a right answer. There are lots of right answers. But you can be wrong. So it takes some judgment and some belief in yourself and your skills of graphing, which can be scary. So to create and write the equation or a trend line or a line of best fit or whatever you want to call it, the first thing you do is sketch an estimated straight line through the middle of the data. Sketch an estimated straight line through the middle of the data. Estimated. Is there such thing as a bad estimated straight line? Yes. But are there multiple different representations of an estimated straight line? Yes. And then step number 2 is to estimate / count Because maybe you won't have to really do a whole lot of estimating. Maybe it's just perfectly there. Estimate or count the M and the B. What does M stand for? Zach? And the B? Y-intercept. Well, because you're making a straight line, so it is going to be a slope, right? But, yeah, it's a rate of change because it's not constant. But we're pretending it is constant to make our line of best fit. Step 3 is use slope-intercept form. Y equals mx plus b. So let's practice a little bit. They're not going to be exact because we don't have values on our graphs. But looking at this positive scatter plot, I'm doing my best to create a straight line. So looking at your positive scatter plot, it doesn't have to start at the origin. That's another trick that people think. Oh, I've got to start at the corner, at the origin. No, that's not true. So we're estimating here. Y equals, because I don't have any numbers. Let's say I go up 1, 2, and over 1, 2, 3. Again, yours are going to be easier because you're going to have actual grids to count. So my slope is 2/3 x. And what's my intercept? I mean, maybe this is 0, 1, 2. So maybe plus 1. And then what Mrs. Newer was talking about is like,
So for that -1.
there's another way of doing it, like it's called the array method,
Okay,
that you draw a circle around it or an oval or an ellipse or whatever. You don't draw like a wonky looking blob. It's got to be a pretty uniform closed shape, right? Don't be like, right? All the way around, and then you just take that shape and kind of divide it in half.
got it.
And that would be a way of drawing your line of best fit. There's another way that involves finding the median of your data, then finding the upper quartile, finding the lower quartile, then graphing between those two. It's a lot of math.
Yeah, that sounds like what your husband probably does.
Right.
Make his estimates. No drawing pictures.
He has good estimates. We have, yeah, valid estimates. So then this one, if we were going to go, I mean, we can go from this point to this point, right? Because there are 2 points on my graph. I still may have to estimate. You know, if I'm actually counting, it may be, you know, over 2.7. Well, I'm going to round that up. Or say 2.5. So if I say up 1, 2, and backwards 1, 2, 3. So my slope is 2 over -3 x. It'll show up someday. A no correlation does not get a trend line.
Too random, right?
Yeah.
I mean, you don't